right. Are you ready? Whoa. Okay. Hello, everyone. Welcome to our October meetup. This meetup will be entirely in English. I'll do my best to speak English today. So, as you know, we kind of changed our name of the meetup to be more inclusive. So not only Kubernetes stuff, but also the platform engineering stuff. So, yeah. Okay. That needs to sync. Hello.
It's
Yeah. All right. Meet the team. I think you saw this slide so many times. So that's me in the middle, and Vladimir and Spas are somewhere there. So if you have any questions about the meetup, and just approach to us and talk to us. If you want to talk at the meetup, you can do it through us, and then at the end will be a QR code that you can scan, so you can submit your talk. So next thing is to thank to our host today, Acronis. Thank you very much again. Also, we have to thank to Pulumi and Isovalent for sending their folks to us to speak. And yeah, once again, KubeCon North America is approaching. It's just in 2 weeks' time. So if you want to attend, virtually or not, you can use that to get a 15% off. What else? Next time is going to be in SAP office on the 30th of November. So I hope I can see you all there. By the way, who is first timer this time? Oh my God! All right. How you find out about us? Like, you're not first timer. I know you. Yeah. How you find out? LinkedIn? No. Meetup? Okay. Facebook ad? Brett? Friends? Okay. So we have to stop the Facebook and LinkedIn ads. All right. That's a little bit cost optimization kind of stuff. So, okay, so we have 2 topics for today. The first one will be from Pulumi, and Engin is going to talk about how to kickstart your journey with the automation infrastructure as code. And the next topic will be by Isovalent, and they're going to talk how you can extend your networking beyond the Kubernetes. So, cool stuff. How you can stay in touch. We are approachable at meetup.com, of course, as I hope everybody knows, and you're registered. You can find us at the Sincere Slack. We have a channel called Bulgaria, and we have Facebook page, so you can chat with us there. Also, you can find all the slides on GitHub and all the recordings that we have a recording of in YouTube. So, with that, if you want to speak to our event, you can use that QR code. Who want to speak? Can I see some hands? No? Raise your hands? No? Wari, I'm expecting you to submit some talks over there. Anyway, use us to a platform to practice your speaking. So if you have something to tell us, like what you're doing at your workplace, or if you find out some very interesting project that you want to share with us, scan the QR code and just fill the form. It's like two lines, and that's it. With that, I think I'm done for speaking now. Let me introduce you again from Pulumi. Come join us.
okay.
And yeah.
Thanks. Thanks. So yeah, thank you. I hope you can hear me very well. First of all, dobre den. So, dobre večer. So, very cool here. I arrived yesterday, and I already had my banica and boza. So, and we went to the Sofia banica place, the little one, you know, where you can only pay by cash. So it was very, very delicious. I liked it. So I already in love with Sofia. That's for sure. Let me quickly pull up my slides. And yeah, Olin, you should stop the Facebook stuff. I mean, there's only my mother and so on Facebook. You're not reaching the real people there. Okay, so play from start. Okay, let me see if this is working also. Okay, that's working fine. My talk, yes, it's a Pulumi talk, so I want to introduce you a little bit more to Pulumi. On the general things you see apply also to other tools in the space. You probably heard about different tools. Maybe you're already using tools like Terraform, so some things should be familiar, but you will see the plot twist on Pulumi. So that's something I would like to show you. Shortly to my person, as you can see, I'm completely coming from a corporate environment, so I worked before in larger corporate, and one thing they told me all the time is, Engin, put a introduction slide, because you only get promoted when the managers see you and see your name and so on. So this is something I kept from this time, always introduce myself, what I'm doing, where I'm working, so when the next time they do a promotion, they think about, hey, there was Engin, he did some talk. So I keep this as a heritage. As you can hear from my not accent, from my accent, I would say I'm from Germany. I live between Stuttgart and Frankfurt and worked before for the Schwarz Group, and I know that there's also a Schwarz Group hub here in Sofia. I had much contact with the people here, so I highly loved to work with the people here in Sofia from the Schwarz IT. So that's something short for me. Of course, I have all the social stuff. This is very important for me because with all the recent licensing changes, and we know now more people do more diligence regarding tool selections, everything you see here is either open source or part of a free tier. So there is no something like it's a closed source or whatever, so you can use this. And I found it very interesting to put on the slide. Just to remember, because sometimes when you hear, hey, it's a company name, is it something with a paid tier or something like this? No, it's free, you can use this. Of course, my daughter and my wife is happy when you would upgrade to enterprise support, because that means that I get money. Pulumi earns the money, just on a short thing, with enterprise support. So that's what everybody's doing, so professional service. I work in professional service, taking care of different customers, automotive and so on, and you get access then to professional service. Okay, so let's start. This is something you will probably encountered in your work life. That's the AWS services. We have the Google, we have the Azure service. So it's really big stuff. And this is mostly how we end up in the situation, like, oh, what I'm going to use here, what's going on. So you're completely overblown. You need to think what you're going to use and how you're going to use. And one of the ways to handle this, and this is using infrastructure as code. So that's the introduction to this, to say, okay, why should I think about this? Yes, a huge variety of services, and which brings us a little bit order into the chaos is infrastructure as code. I don't want to bore you too much about infrastructure as code, because hopefully you already started to using this. So there are two ways to approach for infrastructure as code. So one thing is the declarative approach, and the other one is the imperative approach. So the declarative approach for infrastructure as code is, for example, Pulumi or Terraform. You describe the state, you say, okay, I want to create an AKS cluster, I want to create a bucket or whatever, and the tool takes care of creating this however they do this, and then they put the state of it, for example, and save the state. So Terraform always has a state handling, Pulumi has a state handling, and then you have the other way to declare your infrastructure as code, and this is the imperative way, where you say, okay, I use different calls, CLI calls, for example, to create the infrastructure. Two ways. We're going to focus now on the declarative way. If you ask, like, okay, is there one way better than the other one? I would say you cannot really say. It's again this big question, it depends. So it doesn't mean that one thing is inferior than the other one, and the other one is something you should always say. There is a rule of thumb to say, okay, when does it make sense to use, for example, a declarative state? Yes, I'm a little bit biased. I would say use it all the time. But as a rule of thumb, you would say, okay, smaller projects you can handle in an imperative state. You probably had this in your companies before, having some bash files where you just call the CLIs, AWS CLI, and so on and so on. But for larger or mid-size projects, you should think about switching to a declarative approach and using an infrastructure as code tool like Terraform, Pulumi. The benefits. So now comes the question I would like to ask you, because I put some benefits here, but then it's just me and maybe I'm biased. So my question for you would be, what are some benefits of using IAC? What do you think? And I have 6 on my list, and we'll see if you can guess all of them. So feel free to give me a hint on some benefits. It's on my list. When I click, there comes the solution for the other ones. But yeah, that's true. Security, safety, yeah, definitely. Yes, audit trail and yes, yes, that's also very very important item potency. So yeah, I see you're all already pros on this topic. So I put, for example, in the list cost reductions. So I can really optimize my infrastructure, and I can say, okay, this is the parts I need. Um, Something happened with the stream. I don't know. I put okay. So I don't know. There is no signal. Okay. Magic. So cost reduction. That's one of the benefits to go for infrastructure as code. We also had it here. We have increased speed of deployments. So we don't need to go by hand, or we don't need to run any additional huge bash script. We can just execute our infrastructure as code when we need this. Somebody mentioned the error. So this is also, we reduce our errors. We improve our consistency of our infrastructure. So that's very important. And the last thing, which nobody mentioned is, but I found also very, very interesting to say why it makes sense, is we eliminate infrastructure drift. So for us, infrastructure drift is really, really a big topic. So people use, for example, the console. They have access to the console, and then you have always the situation, I just quickly changed it there because maybe there was an incident, we had to fix something, or there was a ticket, somebody asked, hey, can you increase the capacity, and so on. So people go there, does something in the console. It's not written in your code, so people don't know this, and we know code is also something like a documentation. So people don't see this, and now we have our infrastructure drift for the next time when we create a new infrastructure with the same pattern. We don't have this inside our code, and we just wonder why the changes are not inside our code when we spin up a second stack, for example. So infrastructure drift, preventing this is very, very important. And I did not find an icon for infrastructure drift, if you can see. I mean, there are some nice icons, but I just use a car, so that's a thing. Okay. On these terms, I also created some interaction part for you folks. So I will share this now with you. Let me see where it is. Okay, let me start this one. For this question, I would like that you use your smartphone and just scan the code and give me a short feedback about this one. Oh. Okay. There should be no registration or something like this, just That's cool. That's fine. I can live with this. I'm from Pulumi, but hey, it is as it is. So I'm. That's very interesting. I mean, who used the console? Just for a question. I mean, who wants to be stand up and say we using the G Cloud console? I just want to know why you're using the G Cloud console. That's very interesting. Uh, they're in the beginning. Okay, that's fine. When you're in the beginning, it's okay to use this. Okay, so thanks for this one. That's very interesting. So that's what I assumed also. So we are in a state where people really use infrastructure as code. So we see some of the famous one I really like. That Ansible is also still presented here. So that's very interesting. I like the ClickOps one. So kudos to this one. And we see, that's what I mentioned, so there is no wrong or right on this one, so you can use the declarative one. I know, and this is something we also suggest, for example, for customers in their journey is, yes, it's okay to use the console for your starting because the tools mostly bring you an import functionality. So Pulumi, for example, has a Pulumi import. When you created your infrastructure via ClickOps, for example, or via your CLI, and now you're mature and you say, okay, we want to move now to infrastructure as code, you can import your infrastructure, and that's completely fine, and then it's managed by your infrastructure as code tool. So that's cool. Okay, then let me look for the next slide. Where are you? Okay, so last question, just to see before we head over to the next chapter, is now we talked about benefits, and I on purpose let the whole challenges away because I have maybe an opinion on these challenges, but now comes the question to you: what are the obstacles on your side to say, okay, for working with infrastructure as code? That's cool. Okay, I just let the slide in. That's really good input, and this is something I think partly also we saw now this meetup is also called platform engineering, and I see most of the parts also as shifting slowly over to a platform engineering team to say, okay, they provide you with the golden path, with the way to handle this, that you maybe not end up in this kind of situation. So bootstrapping, onboarding people, for example, could be much more easier when there's already a golden path from the platform engineers for you, where you can just go and order your stuff. So backstage, for example, is a big topic and worth to check. State management, honestly, state management can really be messy when you screw up your state. So that's also something I really relate to. And there's also a term like state surgery, where you really export your state and then you go through this. So that's something where you have to take care. Complexity, of course. Again, this is something where I highly advocate to say, okay, we need a platform team which thought about some of the provisioning using this golden path principles and say, okay, we take away the complexity, you can just consume our templates, for example, and that makes life very easy. Okay, so let me continue with the actual part. So play from current slide. Okay, so thanks again for the feedback. So now let's head over to Pulumi, because that's the thing I want to show you. So what's the specialty of Pulumi? So why should people think about Pulumi, and why? That's also one of the most questions we got when we are on conferences, being at KubeCon and so on. So there come sometimes people, they just want to troll us and then like, hey, why should I use Pulumi and so on? I'm happy with Terraform. And like, hey, if you're happy with Terraform, then it's okay, you know. If you have a specific pain, then we can talk about this. But if you are happy with your current solution, do you really want to become the person who advocates for a new solution and maybe it fails because it doesn't, you could not introduce this very well? But here are some of the benefits of why using Pulumi makes absolutely sense, and to consider when you hit a wall with your current setup. And I'm not also talking about the licensing part, which happened with Terraform, but also of where does the journey continues. So we have this three columns here. So we have our build, deploy, and manage part. And as you could see, one of the benefits of using Pulumi is you can use a generic programming language for your description of your code. So you could say, my application code, or we already use Go, we use C#, most of the Azure people, they use C#, for example. You can just continue using your code. So writing your deployments in a generic programming language gives you the flexibility of the language. You can reuse, as you can see, the whole tool chain. So you don't need to create a new tool chain and say, okay, people have to learn a new tool chain. I need to add additional tool sets. When you use Pulumi, you can just use your IDE. You get your IntelliSense. So when I want to create an S3 bucket, I import the library. I just type the dot annotation like dot, and it gives me all the informations with the descriptions of the documentation. So if I'm already using it as a developer, it felt like a new library for me. Still, I need to know what I'm doing. I still have to work with the architectures together to say, okay, what I'm going to create in the cloud. But from an execution point of view, you just feel like it's a library I just can include. Pulumi doesn't dictate what IDE to use. So we have customers using IntelliJ, they're using VS Code. I mean, I saw people using Vim. I mean, they had an issue, they shared the screen. I'm always like this, like, yeah, share your screen, show your code, because explaining code can be tricky. And then bam, Vim, I'm like, what? What should I do? And he's like, and okay, so, yeah, that's not. I'm not Vim shaming. That's it was for me because I'm the IntelliJ person. So, you know, I like my UI and so on. And I saw that hardcore persons, they are like doing everything. That was impressive. So, but it tells us it doesn't. You can use what you want to use. It doesn't dictate anything. The middle part is very important. We have support for all the major big cloud providers. So all the time people asking like, hey. What are the people using? Sometimes people want to compare. They say, what is other people using? So I can say you inside news, AWS is the main player, be it in Germany, be it in America, whatever. AWS, everybody is on AWS. And then there comes nothing, Azure. And then really nothing, then GCP, and that's it. I still wait for my first customer with DigitalOcean. Maybe our customer base is not meant for this. Maybe we are not looking for the customers in this area, but AWS, Azure, and Azure is sometimes very tricky because customers contact me, and as I said before, you can be sure when we have an Azure problem with a customer, it's always C#, and I'm always like, what? I'm not a C# expert, but most of the customers with Azure as a cloud provider use also C# and then GCP. So we have support for all of them, so you can use, you can provision, you can do whatever you need in your programming language with the cloud, and some SaaS providers, very perfect. And on the right side is also, yes, it's code. You can use Git, you can use GitHub, you can use GitLab, whatever you have in your company. I mean, I recently met a customer who use Tekton, for example. They have everything on Kubernetes, and that works really, really well. So this is the part. Now, the whole platform suite, I already mentioned this. Yes, we have inside, we have our Pulumi SDKs. I just go quickly over this. Again, our providers, the language, then the support, so you can create modules, Pulumi module, language specificas, and then you can share this via Artifactory, via npm.js. So you can create code, you can share code with others. So for example, you as a team created the perfect AKS deployment. You just create an npm module out of it and can share this via npm in your internal, and people can just consume this. So you see, we come back again to the platform thinking. So that's already some starts creating an abstraction for people. People don't need to think about the details, they can just consume. So that's over the way they're already used to this. So as I said, our .NET people, they use things like Chocolatey, for example, to share with the company. Let me jump over this. Yes, the provisioner and everything, that works fine. And underneath we have our Pulumi service, where we also take care of some of the, for example, if you don't want to take care of your state, we take care of your state. But we come later to the point of some of the differences between self-hosted state management and using the Pulumi service. Okay. Let me shut this down. Okay. So, just as a little high-level view of how Pulumi is working. So when we start to write our code, we have the Pulumi CLI installed. What is Pulumi doing when we say Pulumi up, for example? It checks which language we are using. It downloads the language host and starts a microservice on your local machine. The Pulumi CLI starts a microservice, communicates via gRPC. So the language host translates the language in the SDK to gRPC calls with the CLI. The next part are then the providers. So is it green or is it no, CLI? And yeah, it's here, it's the provider. So when we use AWS or we use Azure, the CLI detects also which provider we are using, downloads the binary from GitHub, starts the microservice. They also communicate via gRPC, and then the whole story starts to build. I wrote a S3 bucket, create me S3 bucket. Pulumi CLI detects this, starts the provider, makes a create. And the last point is when the operation is finished, the results get saved in a state management. And now you can see in the bottom, there is the possibilities of the Pulumi cloud and self-stored. So we have plenty of huge customers. We didn't even know they exist. They do an S3 bucket classic. They're like, I'm not gonna pay you anything or whatever. We host this on our own, which is fine. Yes, you can do this. So use your S3 bucket. You take care about the state. What you can do, and additionally, which makes very much sense for me in whatever tool you are using, because I always prefer to say, friends don't let friends handle the state file on their own, because we have often cases where the state gets destroyed, corrupt, and then people call up and they're like, hey, my state, I have now orphan infrastructure, I have to restore everything. This is very, very painful. So I always prefer whatever tool you are using, look for shifting the responsibility to somebody else, because you should concentrate on what you're doing. If you have regulations and some government, whatever rules, yes, you maybe have to use your own state, and it's possible with Pulumi, so you can use your own state file. That's perfectly. Continuing with the high-level view, how does a Pulumi project look like? We will see this in the demo in action. So we have our project. That's fine. A project contains a Pulumi program. This is where simply the Pulumi YAML file lies in. And then we come to the stack. This is the interesting part. So now we can say, in our Pulumi program, I define, for example, a variable called x. Now I can create different stacks. Most of the time, the customers or people using Pulumi, they name the stacks like their stages. They say, okay, I have a dev, a pre-dev, whatever stages. And then you can overwrite the values also. So you can do your config management as code separately and say, okay, development doesn't need a big Kubernetes cluster. So maybe they get a smaller one automatically. So you just overwrite these values. Some customers started now also with the whole ephemeral environment. So they're not going with this classical labeling and whatever. They created some process around this to automatically generate during a pull request, for example, a deployment. This was so successful what customers are building with the ephemeral stuff that the product team from Pulumi took this idea now And one of the services you get when you use the Pulumi cloud, again, is free, you get review stacks. So you automatically, when your pull request gets created, Pulumi detects this and create an ephemeral stack just for the pull request. So you get your infrastructure, Azure App Service, whatever, deploy your application on top of it, your testers can test this, or your product owner can check the functionality. The moment you approve it, it gets destroyed, so you don't need to build this. So one less glue code, and you can concentrate. So that's the thing with the stacks. And the real magic happens with the resources. This is where the Lego pieces stick together. So you say, okay, S3 bucket and EKS and whatever you want to use, you can use on the resource level. And interesting part with the resources is the input of a resource can be the output of a resource can be the input for the next resource, and you can build a graph. So what is Pulumi doing in the background during our Pulumi app? It creates a graph and can then execute either parallel or sequential the execution of the program. This gives you a speed boost because sometimes you don't need to wait, for example, that your S3 bucket gets created while the Kubernetes cluster is still provisioning, because they see there is no dependency. The moment you use the input, the output from one resource input, there comes Pulumi puts in line, and it has to wait. So that's very, very nice. So at the end, in the background, there is a graph created which takes care of this. So that's the reason we have this dependency. Sometimes you can even set it by hand. You can say, hey, this resource depends of the other resource, so Pulumi takes care to wait for this one. And interesting fact, we will see this in the demo also, is you can use inputs and outputs on a project base. And now comes, we just talked with somebody here about the idea of microstacks, to say, okay, we want to go away from huge monolithic stacks where we put everything inside. You do an app and you wait 15 minutes because it has to reconcile all the resources, go back to the cloud provider and so on. So what people are using now, and we also encourage for greenfield project, is to say, do microstacks. So create, for example, depending on the speed, for example. So an VPC or a VNet doesn't change that much. So you could say, okay, let's put every network related stuff into one stack, and everybody else who's consuming this VNet because they need to deploy into it, they can just reference to it. So you could say, okay, this is the name of the VNet. You can reference, you can RBAC this and say, okay, you're allowed to reference the dev stack with your dev stack, and so on and so on. So one separation on the speed of the things getting changed. Another separation is of concerns, to say, okay, maybe I don't own the database team. Maybe the database team, they use Python because they are in this thing, or the ML team, they use Python. They know how to create the perfect database compliant with the company rules. So you could use ServiceNow or Backstage or whatever to order your database. They provision the stuff, and now you can just reference the URL and the password, for example, or the user. So I'm not taking care of this. It is completely hidden. The implementation is hidden, and I can just use the output of this stack as an input for my one. We see this in action also. Okay, I hope I did not bore you too much about this, but I found this interesting. This is really the minimum of stuff you should know to have a little understanding on how Pulumi is working. As I said at the beginning, some of the things are very similar to other tools in the same space, so there should be not something like, oh, that's completely new for me, but there are some little nuances and details which I found very interesting. This October was a huge platform release for Pulumi, so we mocked it. We said it's a Plateauberfest. I've tried to coin this and say, let's name it Plateauberfest. So we released our Backstage plugin. We released some additional service around platform engineering in the Pulumi service. And one very cool functionality is this Pulumi environment secret and configuration called Pulumi ESC. I always say ECS, and then people are like, are we talking about now AWS services? No, it's ESC. And we will see this in action. But the idea of ESC is we can now create all the handling of environment secrets and so on the Pulumi cloud, and we can use this now inside different targets. So we have our source. As you can see, the TV will be shut down in a minute. Is Acronis saying we have to leave, or like in the disco with the lights, you know? Okay, so that's fine. Yeah, we have different sources of where we get information. So there's an inbuilt OIDC support, for example, for AWS, Azure, and Google. So we can use the Key Vault, for example, automatically. Pulumi ESC will take care of it. And then we get the informations out and can then donate them, for example, to Pulumi. But not only for Pulumi. I can also use Pulumi ESC to call classical CLI commands, because it just takes care of the environment. So if I use, for example, the AWS CLI, I don't need to do AWS SSO login or something like this. If the platform team or the persons in charge of it entered the OIDC provider on a higher level, I can just consume it and just type Pulumi ESC and execute a normal CLI. I can execute a Pulumi program. We will see this also in action. This is a very powerful functionality. Okay, next thing, what I found interesting from all the tool sets I brought. Okay, perfect. Is Pulumi templates. We talked about this. Templates are a very good way to help people to bootstrap, to kickstart quickly their journey, because you already created for them. You could write your name behind the template and they know to who to ask. So a very cool functionality. Pulumi supports this, and you can just create your own template. You can point to a Git repository, or you can start with the inbuilt templates of Pulumi. There's a huge selection of this. You just say Pulumi Kubernetes Go, and it will create you the scaffolding of your project, and you can just continue on this one. Now we come to the Pulumi Cloud Service. So this is the thing. What do we offer? So we offer that we take care of your state and secret management. You saw with Pulumi ESC, for example. You don't need to save. You just make a Pulumi login, and every Pulumi app you do consequently, we take care of the state. We are SOC 2 compliant, so everything. If you need to know how we protect everything, you can see the implementation details and the report of the SOC test. And secret management, we don't save any secrets, so this is also something sure. Currently, it's all in our AWS Secret Manager we are using, and most customer, they love to start with the Pulumi secrets inbuilt and then move out. So the CISO or the compliance team can say, hey, we got it now, but we want to use Azure Key Vault, for example. We want to use our own secret management. You can use this. So Pulumi supports this. You can migrate away from the Pulumi secrets. Pulumi deployments, we just mentioned this. I will not talk about Pulumi deployments because it's a bigger topic. In a nutshell is we also offer a SaaS solution where you don't need to run your own CI system. So you can just use Pulumi the cloud and it will automatically deploy your stuff. You can connect this, as we talked about Review Stack, to your Git repository. When there is a change, Pulumi makes a preview. Very powerful functionality, but we are not going to talk about this. Pulumi Insight AI. So if your company doesn't have an AI tool by now or something like this, you should ask them what's for the future, because everybody has AI currently. We started AI in KubeCon Amsterdam. So I'm going to use in the demo, I use the AI part of it. You can think about it's a language model heavily trained with Pulumi and gives you very good input about Pulumi. Policy as code is also very important. If you're using open source, you can execute policy as code also there. If you use the Pulumi cloud, you can configure that every deployment of Pulumi code will automatically check against the published policies. So you can now create a huge library of policies and they get executed automatically. You can say it's mandatory or it's advisory. And the good part is, because we want to be close to our story, you use TypeScript or Python. So that's a good thing. We have also Rego support for the people in the company who are like, I don't know to code. So we expect, or I, to be honest, expect that people who are in charge of the compliance rules, for example, they also start to think about code, and most of them they're using Rego, for example. So we have also this support, but you can also use TypeScript. And then we have webhooks, MS Teams, and so on. That's dashboards, much more. Okay, this is a completely, can you cut this? This is a completely marketing stuff. I took this one-on-one, no, I took this one-on-one from marketing, so it's intelligent, search, analytics, so that's very, very cool. I show this in the UI, and it's really cool. So you can use natural language to define what you want. It will generate you the code. We even think about now with the GPT, our engine is built on GPT-4 to use the image functionality also. So you could just upload an architectural diagram and get your code, but currently it's natural language. Policy as code, let me quickly go. Yes, I just talked about this. Enforcing security, very important. FinOps, that's very avoiding additional costs and having some guidelines for the developers. Shift left, you will hear in this context very often. So you get the feedback while you're programming, for example, your code. You can do a Pulumi preview and see already, hey, I used a too high AKS cluster, and it will give you the feedback. Okay, so now demo time. That's the most important part. This is the demo infrastructure. I'm going to deploy an EKS, first part. Second part, I'm using Pulumi AI to show that we're all going to lose our job because AI is the new overlord. Spoiler, it didn't work all the time. So AI hallucinated much. So sometimes it works very good, and sometimes he come up with stuff. It's like the work colleague, and you're like, hey, I trust you, but it doesn't work. And then I'm going to take this generated workload without anything, put it into the code and see if it works. And that's it. As a language, I use Go and TypeScript, so you have an idea how this is going to work. And bonus points, depending if we have time or not, I'm going to show you also policy as code, but this goes quick. Okay, so let me open my UI. Where are you? Here are you. Okay, so let's close this one. And I get all the time shouted from somebody in the audience when I do the demo. They're like, hey, there's a presentation mode. Every time getting the stuff. So where is the presentation mode? Here is it, appearance. So, okay. And then I have the problem in the presentation mode that I don't see the code I want to show. Okay, you see, that's why I hate the presentation mode. So we exit the presentation mode. Let's show you the Go code first. Where is it? So okay, so this one makes. So this is the code, the Go code just created here for an EKS cluster. Not going too much into detail because maybe not everybody is familiar with Go, but as you can see, I just use all the things the language is offering me here. I could also create additional, how do you say this, additional functions and so on. It really depends on how I'm going to work. Here you see I just create the ECS infrastructure, I create the routing tables, and here comes one of the first plus points I really like, and we got feedback from people using it. You can just use a for loop. this one is very so. So just using a for loop, so I can navigate through the different availability zones, and then define the cluster. So this is how you create the Pulumi code. And now we come into the situation. I want now also to deploy an application load balancer, so I create all the IAM roles also inside my code. And as a final step, I'm deploying here, I create now the Kubernetes deployment. I'm deploy in the last part, where is it? Here. I do now a Helm release everything by code, and I deploy now the application load balancer. This is one of the parts. Very, very cool. As you can see, some languages are generate a little bit more code around this. So Go is one of the language which is maybe looks a little bit like, okay, there's much going on here in the Go code. TypeScript is much more compact, or Python, but I want to give you some insights. I personally prefer Go, and I keep on programming everything in Go. So let's move out of this, and where exit, and now we can go into our infrastructure. I can now say Pulumi preview to see. I already deployed it because we don't want to wait 15 minutes because EKS can be a pain. So you see, I already somehow you cannot zoom here. Yeah, that's IntelliJ. That's shit. It doesn't allow zooming here. But just do the Pulumi command. And we will jump now quickly out of this because we want to see now the UI. In additionally, so here we can see now the Pulumi cloud. There is a project already created here, our Meetup infrastructure. I have here my stack. I can see we talked about the benefits of IAC. We'll see now the audit trail, who did what, which change. I can move back to the Git repository to see what was attached to this, so it's really connected to everything. And I see here the updates. We see that preview worked fine. Nothing gets deleted or changed, so that was completely, as expected, no changes. So we come to the point where we said, what is Pulumi ESC? So what I did is I created now here this environment. Let me zoom this here. This entry, I say, please, instead of defining configs here, I can still do this. The both ways are support. There's still a way where I could say also here config and start to put configs in, but we said, okay, since now with the new release, we have a way now to handle configs and secrets centrally. So this is how you include this. And now you have the possibility here with the new Pulumi environments. Come on. So I see now, where is my Sofia meetup? Here. So I created here, for example, the OIDC connection here in Azure. So you saw when I did a Pulumi preview, it didn't ask me at all about the AWS login. Everything was already done here. So I can change it. So now you can think also about sometimes owners of properties of informations may not be the persons who program it. So now you can say, okay, I create an access control, and these persons come in and they can change the values, for example, of your IDP. Okay, so now we want to go to our application stack. So I show you when we go to the application, it's empty. There is nothing inside. So I prepared a prompt. This is my prompt. I say, hey, let me see. I say, imagine you are a Kubernetes application developer and you need to use a stack reference. Okay, I'm very quick. So you need to use a stack reference to get the kube config from the infrastructure stack, and then you create an Nginx deployment with a hello Pulumi world inside. You expose the ingress using the application load balancer, and that's it. So that's my prompt I give. So let's see. Quick. We go to Pulumi AI. Okay, you see this is the Pulumi AI view. You have different language to choose, and then it will ask you. So let me take now my prompt and copy paste this one. I lose time because of watching like this. So okay, and we go here. And we can say now I want TypeScript, that's fine. I say generate. Yeah, I hope he will handle the AI. So let's hope that something will happen here. If not, I prepared a plan B because you can save some of the results already. Okay, the system takes a little bit longer. So I created here already a conversation. So this is the one I prepared beforehand. You can see everything is there, created by the AI. So now we go into our code. Come on. Go in our index. Where are you? In our index TS, and just copy paste the stuff inside. Let me see, is there a change? So this is data and not config. You see it's not 100% perfect. And then we go into our Pulumi application TS folder. Here, because I run this before, we just need to change the reference to Meetup. Meetup minus, yeah. And remove the starting B. Okay, is it okay? No, it's not okay. I don't see this very well. So DDEN, and then we remove the B of Meetup, and then we say infrastructure. Okay, and now we can say Pulumi up. Okay. We can also create a dev stack here. And now, hopefully, if I did not do any error, yes. So we see now, it will generate now for me all the resources, the Kubernetes resources, and I can just apply this. I can say, yes, do this. And now it will get the kube config from the other stack. So I'm not the owner of the EKS, and will deploy all the Kubernetes stuff to it. We don't have time to show you this in action, but let's just short a second. Sorry for stealing the time. So we can say, I want to use the kube config. So can we get please the kube config out? So we say Pulumi stack. So Pulumi stack output gets me the kube config. Where I'm in infrastructure, go. Pulumi infrastructure, go stack. Minus S def. Okay. So now we say export kube config, and I saved it into this KC YAML, and now I say K9S. Sorry. So Pulumi env. Where are you? Yep. So wait. So that's called Sophia. I'm finished. I'm just a second. So I said to you, you can connect every CLI to it. So I use now the K9S. Oh, space. Now it gets. So I did not do an AWS login to this. So now I can connect to my cluster, and as you can see, the Nginx is running. and it's served. So let's see quickly if we get the service, the load balancer IP. It didn't show us a load balancer IP, but okay. There is it. Okay, so I just take this one here and make a curl against this, and if AWS is quick, sometimes it takes time to get the, and we see here, hello Berlin Puck, because it was saved from our before stuff, so it worked. So the AI managed to create us our deployment. The deployment also works, gets the stuff out, and as you can see, we learned now stack references. We saw how to connect to stuff, and yeah, everything in code. I hope it was okay for you folks. So any question? Do we have time for questions?
Yes, we have. Let's make some noise.
Thank you. Thank you.
Let's take quick questions, 3 to 5 maximum. Who's first?
Hi.
Hey.
So we're currently using Pulumi quite a lot in our company. And yeah, I wanted to ask, when do you guys envision the GCP and the other major cloud providers would have a native client, like a native SDK?
It's already available. So you have GCP, Azure, and AWS have a native provider. You can use this. Here we are depending on the service of AWS or from GCP, so they're not exposing everything which is possible with the classical providers. So there's some things that we talked with GCP and they say, hey, this is completely our fault. Our API doesn't expose currently everything. So one suggestion we always say is mix them both. So use the native one, and if there's some functionality missing, for example, then just add the native one, because most of the time they are mixable. I like the Azure native one very much because it scrapes the ARM endpoint of Azure, and you get all the property names are the same and so on, so you can really work on this one. And it's in my opinion one of the best ones for automatically generating via the Open API specification they have. Yeah, the other ones we say we're carefully in terms of maybe it's not some things is missing. AWS native, I would say you can already use, but the Azure native one, yes, it's a very perfect one.
What would you say are big positive things that Pulumi presents that other more established tools don't? Like, for example, I know you do encrypted state, so stuff like that, probably.
Yes, I mean, there are some values to say, okay, not only that you can use a programming language, but some of the things is the batteries included of the secrets, for example. That's very nice. So that's what we always get also as feedback is, hey, I can just start using the secrets. I don't need to think about creating an extra infrastructure for my secrets. So you can just build. I can git commit everything inside. So because it's already encrypted. If I'm not using the Pulumi cloud service, everything is also local. So you just need to enter a passphrase all the time. Or if you use a CI system, you can set an environment for this one. That's one thing. And then as you can see, looking for extended value. So the product team is working on this. So as you see, the Pulumi ESC is very powerful. You can use this in different ways, not only for Pulumi. And yeah, that's one of the things. Thanks. Before you leave, I will take a picture of you with me, because that's a thing.
With me?
With all, because with you I take extra afterwards. So is it okay? I mean, we know we are in Europe with GDPR, so if you don't want to, I will push this into our Slack, but if you don't want to be just so, and smile. Thanks a lot. So that helps our American people there to see how good the events in Europe are, and people are really looking forward to hear more about us.
This is how you get your salary, right?
Hmm? Thankfully, this is not my main job, so I'm in a professional service, so I get my salary from people who need my help. So that's the positive point.
Thank you.
Hey.
Welcome, Nikki. You have 10 minutes.
Hmm? Huh.
It's going to drain the battery in the middle of the. Okay. Let's see how we. Check, check. 1, 2, 3. Works? Yeah. Okay. Малко да го приближиме. Okay. Is my video shown on the Zoom? Is my video shown on the Zoom? Hmm? Okay.
Hello, everyone. We're ready to continue. Please go to your seats. There'll be food and drinks in the end. So
Perfect. Works. Okay.
once again, please take your seats and let's get to the next one. All right. So the next one is by the folks from Isovalent, and they're going to talk about the beyond Kubernetes networking in Cilium. Go on.
We will, yeah. So today is Saint Dimitar's Day. Do we have any Dimitars here? All drunk? No. Everyone is Dimitar. Okay. Okay, I'm going to start. We are going to start actually. Is the sound okay? Good. Okay, hello. So my name is Nikolai Nikolaev, and this is my colleague Rastislav.
Hello.
Yeah, Rastislav Zabo. Am I pronouncing it properly?
Rastislav Sabo.
Wow. Okay. So
Hey.
we are from Isovalent. This is the company that essentially created and donated Cilium to CNCF, and we are going to talk to you today about what you can do with Cilium beyond Kubernetes. I think I hear myself there. Is that okay? Here?
Maybe because I was too close to.
Okay. Great. There's still echo. Oh, it's fine. Good. Okay, so we are at the CNCF meetup. So I'm going to start with a little bit of what CNCF says about Cilium. And I don't know what you can see here, but these are two screenshots from CNCF website. The first one says Cloud Native Computing Foundation announces Cilium graduation For those of you that are not aware, the graduation is essentially the final stage of when a project is being donated within CNCF. I can say that we are probably the only networking, or let's say, CNI implementation solution that actually has graduated. This happened two weeks ago, so October 11th. So we are still in the mode of celebration, and we have some stickers there only, but next time probably we'll bring more. At this point in time, we can say that even the CNI specification, which is also donated to CNCF, is in incubation mode. So it's even the specification has not graduated, but we did. We consider this as a huge success for us as a project and as a community as a whole. What else you will find about us on the CNCF site is it says that Cilium is an eBPF-based networking security and observability. And here, probably at least half of the people here would probably say, okay, what is eBPF? Okay, maybe quick question time. How many people know what eBPF is? Okay, yeah, so roughly half of the people. So let's quickly just run through it, because I mean it's a deep theme, right? I mean there's a lot of things to say about eBPF, but I'll just spend a couple of slides for it. So eBPF essentially is a way to programmatically extend your Linux kernel. So once you deploy your operating system, your Linux operating system with the Linux kernel in it, eBPF allows you to add additional capabilities that are not available out of the box. This sounds cool for some people not so cool. They don't really probably see the benefit out of the box, so let me just try to quickly explain. So here on the picture you can see a process calling exec syscall, which essentially is a way to spawn a process in the standard Linux environment and Unix in general. And we are attaching a program in between the actual syscall, the actual call of the exec call, and the Linux scheduler. In this case, what we can do, I mean, this is very simple program, is just doing some accounting and saying, oh, okay, so you have coded this program this and that number of times, and things like that. So, but you can do more advanced things like filtering. You can, for example, say, oh, you actually are not, you don't have the privileges to start another processes, or you cannot start, I don't know, Nginx on your own because whatever. So this is very, very simple example. But if you go a little bit deeper, here is more elaborate example. I will concentrate on the on your hand, it would be the right-hand path. This is essentially a process trying to talk to the network. You can see that you can attach the eBPF programs at different levels of this network part. So starting from the process, in this case, it's a connect call, which means, okay, I'm opening a socket to this remote server and so on and so forth. But you can attach eBPF programs and actually customize the whole networking stack at all the different levels here. And we have some attachment points enumerated here. You can attach it to particular kernel functions, so meaning that if you know exactly what happens in the kernel, you can actually attach there. These things are called kprobes. User space functions, system calls that we already mentioned. You can do some trace points, and what's most important for us, being a networking solution, I mean Cilium, are the sockets and networking devices, not that much of the XDP at this point. Why all of this is important? So throughout the years, there have been many attempts to make, I would say, proper networking solution within Linux. Let's call it focus on Linux only. And maybe some of you remember Open vSwitch, or maybe some of you know about DPDK, and so on and so forth. And we never managed to get quite it, right? I mean, there was always these quirks, and something was not really matching, and you didn't have the exact version of OVS on your Linux kernel, on your distribution, and so on and so forth. With this approach, essentially you can take, okay, not every kernel, but since particular version of the kernels, at least Cilium supports 4.18, do you know? So everything since 4.18, you can take any distribution that has kernel since 4.18 till, it's 6.5, I believe now, and you will get more or less unified experience. I mean, with the exception of some particular accelerations and features that are available in the more recent kernels, which is, I don't know how many of you can realize, but this is a huge, huge success for the technology overall. I mean, like, us as a community managed to get to this point where we can do this. And this was not available until eBPF came around. So this is more or less about eBPF and why it's important. CNCF is preparing a special documentary about it. It's going to be presented at KubeCon on November 8th. Is going to be its premiere. There is a trailer available online if you're interested. And it's called Unlocking the Kernel. I'm proud to say that half of these people that here on the poster are actually our colleagues at Isovalent, one of our founders, Liz, who probably most of people know, Daniel, and so on and so forth. Please check it if you want to know more about the history of eBPF, how it was created, and probably some of the future. I don't know the exact details. Anyway, so based on eBPF, we are implementing the so-called CNI. CNI is essentially container networking interface. So it's kind of a specification which essentially says everything that can pass a packet from one pod to the other is implementing the CNI, more or less. Okay, there's some other requirements there. How do we do that? We attach eBPF programs to every pod. So for those of you that know what actually lies behind the pod, it's a networking namespace. So there is an eBPF program that's being attached to that. And from there, we essentially take control of all the traffic and can do various interesting things, which some of them Rastislav is going to talk about. Here is a quick overview of the whole ecosystem around Cilium. So at the bottom you see the Cilium networking, but even this is already big enough. So Cilium became, over the years and over time, became very, very complex ecosystem of many modules. So here you can see load balancing, encryption, network policies, of which we are very, very proud, and probably people that are here probably know a lot. But on top of that, we are building also observability with Hubble, which is again based on eBPF. And we have our service mesh implementation. I think that last time you had the Linkerd presentation, yeah? So this is a slightly different approach that we do. It doesn't rely on sidecars. There's some debates going on in the public, in the communities. Which one is better, sidecarless? But I leave this to some other discussion. And last here on this slide, you can see on the right, we have Tetragon, which is runtime security. It's not exactly part of Cilium anymore at this point, but it's kind of an adjacent thing to it. So you can also enable it, and it has some security features that you can enable, which are very interesting in certain scenarios. On the bottom, you can see some logos. They're here for different reasons, but I just want to somehow highlight that there are very high chances that if you're using today any workloads on EKS, on AWS, the managed Kubernetes, on GKE or AKS, which is the Azure managed Kubernetes, and even some of the the Chinese public cloud providers, that you're already using Cilium, because we are essentially the default CNI within these clouds for one reason or the other. And with this, I'm giving the word to my colleague Rastislav Zabo, who is going to talk a lot more in details into some of the these smaller boxes that I could just show on previous slide.
Right.
Thanks.
Thanks
Okay.
you, Nikolai. Thank you, Nikolai. Yeah, hey, again, I'm Rastislav Sabo. I'm based in Slovakia, so I'm a visitor here in Sofia. It's very nice to be here, and I'm glad that I can speak here about some advanced networking features that we have in Cilium. The reason is that I'm a software developer that works on those features in Cilium specifically. So today I will show you how Cilium can help you to expand networking even beyond Kubernetes. So you would kind of naturally expect that networking for you works within the cluster when you deploy any CNI. But with Cilium, you can expand that networking even outside of the cluster. And I've split these features. I will walk through some of the features that we have in Cilium, and I will speak about them in kind of 3 use cases. First will be use case focused on data center or corporate network integration. The next one will be multi-cluster connectivity. And the last one will be the most advanced one, and that will be about interconnecting with some external networks. So let me start with the first one, data center and corporate network integration. So let's say you deploy an on-premises Kubernetes cluster, and one of the very first things that you need to solve is how you get the ingress traffic into your cluster. Or in other words, how to expose the services running in your on-premises worker nodes to the outside world. If you have a Kubernetes cluster in one of the cloud providers, you would just create a service of type load balancer, and it would automatically work for you. The Kubernetes controllers and the infrastructure would assign a load balancer ingress IP for that service, and the cloud resources are automatically configured so that the packet that goes to the ingress IP allocated for that service goes down to your worker node and to the pods that are backends for that service. But on premises, you somehow need to figure this out yourself. And one of the best options that you have is to use BGP routing protocol for that. So BGP routing protocol is mostly used in the core of internet, but it's also often used in data centers. And with Cilium, we already have BGP control plane built into the solution. So you can use the BGP control plane in Cilium to peer your worker nodes with routers in your infrastructure that are capable of peering via BGP. It can be even your home router if you have a cluster at your home. And the worker nodes that are paired with your router or routers, can be one or multiple, those Cilium nodes will announce all the service IPs or pod siders to the routers. And the router then can do equal cost load balancing between all the worker nodes that announce that particular service IP. So whenever there is some ingress traffic, they can load balance between all the worker nodes that are capable of processing that incoming workload. In order to configure that in Cilium, you need to do 2 things, basically. It is all configured by CRDs in the cluster. So you first need to define some load balancer IP pool from which your services will get IPs assigned. And on the right side, you can see an example of the actual BGP configuration, which defines which nodes in the cluster will peer with which routers in your infrastructure. That's kind of the bottom of it, the neighbors section. And which services will be announced through that peering. Okay, in case that BGP is not an option for some reason, that might be that either you don't have any BGP capable router in your infrastructure, which is pretty unlikely, but another reason may be that because of corporate policies, you cannot effectively configure it because it is a different team that manages the networking, and they would not let you just mess up with their BGP configuration. That is a very often scenario. So in that case, you can use layer 2 announcements, kind of a similar feature, but in this case, the Cilium nodes would not use BGP to announce those services, but it would be all based on the layer 2, so address resolution protocol. Essentially, the nodes that are capable of processing that ingress traffic for a service would, one of them will be selected and would reply to ARP requests that the router is making. Great benefit of this solution is that the router does not need to be specifically configured for this scenario, but the big disadvantage is that you are not load balancing for all the ingress traffic, at least for a given service. All the ingress traffic always goes to a single node, and only if that node fails, then the traffic is redirected to a different one. Configuration-wise, it's similar to the BGP announcements via CRD, Cilium L2 announcement policy, where you define which services will be announced from which nodes, and you also specify or may specify which interfaces will be enabled for this feature. Okay, next feature from this section is a standalone layer 4 load balancer, or L4LB. This is a similar use case, I would say, like similar to the previous one. This feature you can use in comparison to the previous one, standalone. So you can use standalone L4LB feature of Cilium to turn any Linux node into a load balancer. And that load balancer does not have to be used for load balancing the traffic that goes to your Kubernetes clusters only. It can be actually used to load balance between multiple Kubernetes clusters or Kubernetes clusters and some legacy infrastructure. In general, any load balancing that you may need, but is like one level above the Kubernetes cluster. In the example, on the pictures that you can see on this slide is an example of usage of this feature from the company called Cesnam.cz. They changed their load balancing solution from IPVS-based Linux load balancing to this layer 4 load balancing that is based on XDP. XDP stands for Express Data Path. It's a kernel feature that allows to process packets very efficiently even before any memory is allocated for the incoming packet, so on very low level close to the network interface card. So these are actually their results where they compared the situation before and after. So L4LB is the Cilium-based case. On the top right side, you see packets per second comparison. So it's like the performance is much higher. And at the same time, on the lower picture, you can see CPU load used for that processing, and as you can see, it's much lower in comparison to IPVS for the XDP case. Okay, this is another example of this exact feature. So standalone layer 4 load balancer example from a close topology data center. It's like more advanced example, just to give you an idea how this can be deployed. So those nodes which are labeled with L4LB on the right side, those are running Cilium layer 4 load balancer, and they load balance all the incoming traffic for the normal Kubernetes workload as well as legacy infrastructure and other Kubernetes clusters. And the last feature from this section is Egress Gateway. Egress Gateway is a feature that is about kind of exactly about the opposite in comparison to the load balancing. So here we are talking about pods in your Kubernetes clusters that potentially may need to access some service within your infrastructure that is protected by a firewall with very strict firewall rules. Let's imagine that we have some legacy database. In front of that database, we have some firewall, and your security team told you, okay, we can allow you access to this database, but only for a single IP. And there's a problem in Kubernetes, because in Kubernetes, of course, we have multiple worker nodes with IPs that can actually change, because nodes can come and go. Same for pods. Pods can come and go, and their IPs constantly change. So normally it's not possible to satisfy this security constraint. But with the egress gateway, you can achieve this. You can create an egress gateway policy, which would define, okay, for pods labeled with these labels going to this destination, I want all the egress traffic to have this source IP. And Cilium would forward the packets to the proper egress gateway node, where it would be source netted so that it can pass through that firewall. Okay, so that was about data center or corporate network integration. And now let me go to multi-cluster use case. So what is multi-cluster? Multi-cluster use case means that you may need to deploy multiple Kubernetes clusters for whatever reasons. One of the reasons may be that you want to have some of the clusters on premises and some in cloud, or you have some other reasons why you need multiple of them. And you still need to interconnect the workloads running in them somehow. And with Cilium Cluster Mesh, you can actually join multiple clusters into a single cluster mesh. And within that cluster mesh, all the networking and all the Cilium features work as if they were running in a single cluster. So the pods can communicate across the clusters. You can reach services across the clusters. You can use encryption for that communication. You can use observability tools that we have in Cilium, security policies, or even features like service mesh across all the clusters in the cluster mesh. Now, cluster mesh has multiple use cases. I'll show you some briefly. So this slide shows an use case where you are trying to reach high availability. So we have two clusters which are kind of running same workloads. There is similar or the same backend service running in cluster 1 and cluster 2. And you can configure this service to be global within the cluster mesh. And whenever there are no local backends running in, let's say in this case, cluster 2, because they have failed, they have restarted, they are stuck in restarting, or they are being upgraded, then Cilium can automatically fail over to the backends in the other cluster. Another use case, let's say you have a cluster which provides some special service, which is labeled as shared services on the bottom of this slide. In this case, it's a vault service. And you would like to consume this vault service from other clusters in your infrastructure. So you can define that vault service as a global, and the cluster 1 and cluster 2 can consume that service from shared services cluster as if it was a local service. Another use case similar to the previous one, now we are trying to split the services or the clusters between stateless and stateful. So on the bottom we have some stateful cluster which runs some data store service, which of course needs some storage, and you may want to, for example, run it on premises to have your data on premises and on the cloud. But you can have some stateless clusters, and they can even run in cloud, which just consume the data store service from the stateful cluster. And whenever you have such a global service, you can even specify what is the service affinity. It can be either local, which means that in case that the local backends are running, they are preferred over the remote backends. But it can be also remote, and in that case, you would always prefer the backends running in the remote clusters over the local ones. And all of this can be configured pretty easily. So in order to make a service global, you just put an annotation on it, IOCilium global service true. And via the other annotation, IOCilium service affinity local or remote, you define what kind of affinity you want for that service. And from the security perspective, as I already mentioned, you can still use Cilium network policies across the clusters in the cluster mesh, and you can even refer to the individual clusters in those network policies. So here in this network policy, we are allowing specific pods in cluster 1 to contact specific pods in cluster 2. Okay, so this was the other section, and the last one is about, I would say, advanced networking concepts, and that is about interconnecting clusters with some external networks. The first feature that we have in the Cilium feature set is called NAT gateway, so Network Address Translation Gateway. And this can be used to interconnect networks of different types or of overlapping addresses or different types of addresses. On this picture, we have an example where we have IPv4 only internet node, X node on the left side, and we have IPv6 only Kubernetes cluster running on the right side. And what we can do with the NAT gateway is that we can put a gateway in front of the IPv6 cluster, and that gateway is able to translate between the IPv4 requests and forward them with properly translated automatically mapped address to a Kubernetes cluster, IPv6 only pods. Or conversely, now we kind of turned that picture. On the left side, we have IPv6 single stack cluster, and on the right side, we have IPv4 only external node. And if these IPv6 only pods want to access IPv4 internet, they can use the egress gateway, NAT gateway, to first translate the DNS responses from the public DNS server. In case that the DNS response would contain only IPv4 entry, it can be translated into IPv6 4A entry, and that can be later used for actually accessing the external service via the egress gateway, NAT gateway. Yeah, I'm not going to go much deeper into the feature. If you are more interested in this one, we have details on this in the Cilium Release 113 blog post. You can look it up there. And the very last use case and the most advanced and exotic, I would say, is the segment routing for IPv6. Again, I will not talk too much about the details. Just want to give you an idea what's possible with Cilium and with eBPF. So segment routing for IPv6 is like advanced network programming framework, which is built on IPv6, and it actually leverages very old source routing paradigm where part of the packet is encoded at the source instead of deciding per hop where the packet goes. Whole path is encoded at the source at the beginning of the path. And this can be used for various use cases. It can be used for some traffic engineering, so you can tell, okay, these packets need to follow this path and those packets need to follow other path. It can be used to create virtual private networks between the cluster and some external networks. It can be used for service function chaining, which is essentially you can tell that packet needs to go through several processing nodes before reaching some destination. And yeah, in case that you would be interested in details, there was a great talk about this at KubeCon North America 2022 by Daniel Bernier from Bell Canada and Louis, our colleague from Isovalent. There is also a demo, so you can find it on the internet. Yeah, and if you wanted to go deeper into these or other Cilium features, we have tons of labs available on our website. So you can scan this QR code. It will direct you to a map, actually a graphical map, to which you can navigate and take various labs to learn about the features in Cilium and how exactly they work. I would highly recommend taking those. They are a very good learning source. And that's it. Again, if you want to learn more, you can check our website or Cilium.io or eBPF.io sites, which are great sites for learning about Cilium and eBPF technology. Thank you.
Thank you. We have some time for questions. I have one question for multi-cluster connectivity.
Mm-hmm.
How easy is to add more clusters in automated fashion? Because I mean, in terms of security, there should be something approving
Yeah.
those new clusters.
In terms of security, it is based on certificates, MTLS. So yeah, I think probably it wasn't that easy at the beginning when we first released the feature, but it's being improved, and I expect that it will be better with each Cilium release. At the beginning, it was quite manual process, but yeah, colleagues of us are working on making it easier.
Yeah, it's also RBAC. I mean, like for the CRDs. I mean, just normal RBAC.
Hi, I have a question regarding this NAT 4664. Aren't those pods or external instances, or how do you deploy those?
Yeah, so I can maybe show the picture.
No.
Yeah, already went through it.
Yes.
Right. So on the right side we have pods, and that's a standard Kubernetes cluster with a slight difference that it runs only on IPv6. You can deploy any Kubernetes cluster on IPv6, not in all cloud providers. At some, you can deploy dual stack clusters, which are both IPv4 and IPv6, but you can deploy IPv6 only cluster on premises quite easily. That is actually being used for some telco use cases, for example.
That's clear, but where do you deploy the NAT?
NAT, yeah. Yeah, up to you. Of course, it needs to be reachable from the internet somehow, right? So if it's on premises, then you somehow need to figure out the routing within your infrastructure again. But yeah, pretty much you need to deploy it close to your cluster.
Yeah, but it's not part of the Kubernetes cluster itself. It's a standalone instance living on a bare metal or virtual machine somewhere.
I mean, if you really tried, you could somehow figure out way, but normally it would be standalone.
Standalone instance, not part of the ingress?
No.
Mm-hmm. Yep.
Okay. Like the layer 4 load balancer.
Yeah. So I remember back in the days you introduced sidecarless service mesh. That was kind of the thing of the day. And I remember that back in the day there was like some issues with the MTLS. Actually, it was non-existent as far as I remember. Do you guys have any advancement in that regard? Because that was probably like 2 years ago. So do you have any advancement on the MTLS part and the identity part of the service mesh?
I think we do. I have to check. I mean, we're indeed doing some other things.
Yeah, in the last Cilium release, there was a huge update of service mesh, and there is SPIFFE SPAR-based authentication. So you can check that.
Perfect. So the SPIFFE SPAR, they are handling the certificates, I guess, issuance and so forth in the MTLS part, or?
Yeah, I'm not sure about the details either. Just talking from the top of my head.
Here.
How does the service discovery works with the multiple clusters? I mean the DNS.
Yeah, that's easy because DNS works exactly the same way. Again, I can open some. So we have the backend service now in cluster 1 and cluster 2, and that service physically need to exist there in each cluster. And you use the service as it was local, right? You just annotate the service with. Yes. It's just a single service, right? So it's a backend service in namespace X. You just annotate it and make it a global instead of local only. Yeah. You cannot have local only service with the same name in the same namespace. Yeah, there isn't actually an API communication happening between the clusters. I don't think I have architecture picture here, but you would find it on the Cilium site. That will be pretty clear.
Hi, I was wondering how eBPF works with other security tools like SE Linux, for example. Do they understand each other? Do they play nice?
And I wouldn't. Yeah, that's a hard question. I'm sure that someone at the company has tried it together because customers and yeah.
One more.
Yeah.
No more. Thank you.
Wow.
Thanks.
Okay. I just wanted to quickly thank you, Orlin, Spas, and Vlado for keeping to organize this for so many years already. And yeah, thanks.
Now we're gonna have a pizza, and please stay
Mhm.
on your place.